Hi, everyone. My name is Daryl DeFord, and I'm an assistant professor of data analytics at Washington State University. And most of my work is focused on building tools for detecting and combating gerrymandering. And so today I'm going to talk about a couple of really cool innovations from the last few years that have allowed sort of the broader public to get involved with the districting process sort of right from the get-go. And show some examples of ways that this has been used in practice in the current redistricting cycle, and also suggest some ways that anybody who's interested can get involved in, both sort of building their own maps as well as performing some of the analysis that gets used to sort of tell whether a map is reasonable or not. And so just as an overall outline, talk a little bit about just the basics of redistricting, the problem we're talking about, then looking at an example of a browser-based app for sort of building and evaluating maps on the fly, and then wrap up by showing you some templates of some Markov chain sampling software that's being used in perform efforts and in court cases to help design good maps. There's also this sort of URL at the bottom of the slide here that goes to a Google Doc that I'll show you in a second, that sort of has a bunch of resources, both in terms of extra readings if you sort of want to learn more about this field, as well as a bunch of sort of suggested interactive sort of activities. They're good both for the teaching setting as well as just for learning more about the material and kind of what's going on in this field right now. So to begin with, when we're talking about districting plans here, I'm mostly going to be talking about legislative districting plans. So once a decade, the new census data comes out and we redraw sort of legislative districts within states, congressional districts for the House of Representatives. And the sort of plan for those is mostly they each sort of elect a single representative. Everybody inside the district votes, and then the winner, the plurality winner, sort of gets to represent that district for the next sort of time period. And one of the interesting things about districts is that there's a lot of different rules across the country. So there's no sort of hope for a black box algorithm that's just going to give you the best districting in all cases. And that's because each state has its own set of rules, and those rules differ not just sort of between states, but also within states when you're talking about sort of different levels of districts, state House districts versus state Senate districts versus congressional districts. And so not only do they differ in terms of sort of procedural aspects, who gets to draw them, who votes on them, who gets to sort of make the initial decisions, but they also sort of differ in terms of what makes for a good district, what sort of constraints you're required to consider, what sort of things you're supposed to be optimizing for. And so this is a problem sort of domain that doesn't just want sort of computational expertise, but also a lot of sort of input from social scientists and political scientists and legal scholars and people who are really invested in the communities themselves, and not just sort of algorithmic answers to and so while these rules differ between states, there are some commonalities. There are some things that tend to apply in sort of all states and situations. Things like population balance, right? The district should have about the same number of people in them. They should be reasonably compact. They should sort of look nice. There's sort of federal laws governing some properties of districts, including the Voting Rights Act. Lots of states ask you to consider preserving things like county boundaries, municipal boundaries, or sort of investigate and define communities of interest to preserve them. There's questions about whether or not you're supposed to use partisan data to analyze the districts. That's something that states do differently. And so all of these sort of different metrics and constraints are things that have to be evaluated and modeled to try to understand what a good districting looks like in your particular state context. And so over the last decade, there's been a real sort of large advance in using computational and data-driven techniques to analyze plans. And a lot of this got started with an interesting paper from a couple of political scientists called Unintentional Gerrymandering, where they sort of showed that you could use computers, you could use sort of the data that was available to generate a big collection of plans that satisfied sort of versions of the legislative constraints, and use those to compare against enacted plans. And so that got used quite a bit over the last cycle, particularly in court cases. Several sort of mathematical groups got involved to do this in places like North Carolina and Wisconsin, in Pennsylvania. And the goal there was to show that, if you built, 1 million plans or 1 trillion plans, depending on your method, that sort of all seemed to satisfy the rules of the state, and compared sort of the outcomes there to the enacted plan, you could maybe show it was kind of an extreme outlier. Maybe something had gone wrong or should be overturned. And then once those sort of methods came into common use, they sort of got applied to a couple of other problems. So the first one was trying to determine the likely could sort of successive reform efforts, trying to understand the baselines of various states' political geographies under different measures that the political scientists had defined and used and liked, as well as to try to understand, if you were going to enact a particular set of reforms, what the likely changes to those metrics were going to be. Was it going to be the case that it was going to make it harder to gerrymander if you sort of made it a more strict criteria around preserving county boundaries, or were there going to be unintentional consequences if you ramped up particular constraints? Was that going to make the shift in sort of the partisan balance more unfair than it already was? And so these same tools, generating large collections of plans, what's come to be known as sort of the ensemble method, has been used for that as well. And more recently, so we're right in the middle of the current cycle of drawing new lines. And so this is the first time that a lot of these sort of public-facing, open source and open data tools have been available, not just to map makers or consultants, but the broader public. And so there have been questions about how do you use these methods that sort of originally grew up in this adversarial setting of trying to detect specific maps as gerrymanders, to try to understand what a good map might look like, and how do you support states and commissions that are trying to do this well. And so this is sort of the context that I want to talk about today, in two sort of avenues of data-driven advancement that allow the public, citizens, to get involved with this process and to contribute both in terms of designing maps as well as sort of evaluating their properties. And so we'll hop over now and look just briefly at that Google Doc that I mentioned that has some of these resources, and then look at some sort of live examples of how to both do sort of some browser-based line drawing as well as apply some of the markup chain sampling techniques. Okay, so I mentioned a Google Doc full of resources. It's linked in that slide, tinyurl.com/Gerry-resources. And so there's a few different things here that I just want to kind of highlight for you. So it starts with a collection of readings. So if you want to learn more about the rules in your state or states that you're interested in, that first link takes you to sort of all about redistricting, which is a really, really useful site. There's also some more technical introductions to some of the methodologies, the ensemble method and MCMC more broadly here, as well as just sort of a Dropbox folder with a large collection of background readings in this field, some of these papers that have come out over the last couple of decades on the computational side, as well as a project that I want to highlight down at the bottom here. So last summer, I worked with the University of Washington's Data Science for Social Good program to help supervise a team of graduate student fellows who did a bunch of really interesting research about ways that you could use these methods to evaluate sort of initial plans, thought through some modeling questions that need to be considered. They looked at a bunch of case studies and did a nice job of sort of pulling all of their information together there. So this link takes you to sort of the large project website and then the specific document that they talked about. So the first category of really sort of interactive work that I want to talk about is software for drawing lines, drawing maps right in your browser. So I'm going to show you an example here of the Districtr software, and I'm just going to sort of show you the interface, walk you through it real quickly. If you're sort of interested in doing more, using this, say, in your classroom, or just to learn more about the problem, we had a collection of sort of challenge problems linked here to sort of make use of the software and sort of try it out in some specific states with some specific challenges, as well as another exercise that asks you to start at the beginning of the process and go to the individual sort of legislative text and then try to extract from that the type of rules you should use and then use those to guide your lawn drawing itself. So that's one thing. There's actually a bunch of these sort of tools out there. I've linked a couple more here, District Builder and Dave's Redistricting Out in particular, as well as some links to compilations that have a bunch of both sort of open source and proprietary, either paid or closed source software versions of this. And these kind of tools have become really important in terms of public access to the redistricting process over the last cycle. So, lots of states have adopted portals where people can sort of submit or evaluate maps. And a lot of them are built right on top of this software that try to, make it really easy for you to sort of on your own, on your computer, explore the space of possible maps, try to figure out what would work best for you. And another way that these softwares get used is not just to sort of try to draw entire maps at once, which is sort of a complicated problem, but also to gather information about communities of interest, right? It's a much easier task to sort of go ask people, what areas do you think should be grouped together? What sort of areas are important to you to be represented together? that you know about in your region, without sort of requiring people to draw an entire map. So we'll hop over here and look at Districtr. So this is at districtr.org. And it's really easy to get started with line drawing here. So there's a bunch of information throughout this webpage, guides about how to get started. There's training materials linked here. But I'm just going to walk through the map drawing interface. So here we can go over to Virginia. And so this software comes from the Tough Space Metric Geometry and Gerrymandering group, where they've done a lot of really great work about making software tools like this sort of publicly available. And we'll take a look at the congressional districts. We'll open up that tab over here. This is just going to take us to a map of Virginia. And if we want to sort of start drawing the lines right away, or we sort of want to zoom in and be a little bit more careful about which units we put with which, we can do that. So if we want to start drawing, we just hit this paintbrush up at the top. It's going to give us a collection of colors, sort of one per districts, and we can start sort of building these up all automatically. Get something going on here. The bar over there on the right panel is showing the population of the district so far. So we want to get that sort of balanced, right? And so in this case, an ideal district in Virginia for the 2020 data comes out to about 784,000 people. So we'll try, maybe we'll make a couple districts here. That one's a little too big. Trim that down, make a third one here, something like this. And so in addition to the sort of population values, Districtr is also sort of keeping track live of a bunch of evaluation of the data, both in terms of sort of the demographic breakdown of the regions, as well as sort of the partisan information about the districts that we draw. So we go over here to this evaluation tab and say ask for the election details. It's going to tell us, of these districts we've drawn so far, this first district looks like it's leaning about 42-58 to the Republican side. This sort of light green or dark green district, about 80% Democratic, and about 50-50 on this teal district so far. So it's keeping track, and as we sort of add additional units, those values are going to get sort of updated and tell us how they're changing. If we want to sort of see how the people are distributed across the state, we can use this data layers tab. And it gives us a couple of different things. So it can first show us the painting we've done so far of defining our districts. It can also, if we're interested in saying, starting with the old districts and perturbing them, it'll give us that information. So this was the ones that were in place in the 2 cycles ago, and then the ones that were in place in the most recent cycle. We might also just look at the county boundaries and say, okay, we want to build maps that really prioritize those. We want to see, maybe if we turn our districts back on, sort of see places where we should try to line up a little better with those district boundaries, county boundaries. So here, maybe we want to get that collection to get that whole county in that district or something like that. This will also show us information about both the elections, if we want to see sort of on a region by region, a precinct by precinct basis, what the election totals were. We can also look by race. If there's VRA concerns in your state, you need to be building sort of majority-minority districts to satisfy those concerns. Then you can sort of look at that as well based on the census data for each region here, each precinct here, and that can either be done with total population or voting age population. And so this type of tool has become sort of really popular and really useful, and it's sort of a great thing to play around with a little bit and just try to build up some intuition for the trade-offs and sort of consequences that go along with line drawing, and see some of this tension between the different types of rules that are out there for making good districts, and see how the constraints interact with each other, see how the geography of the state sort of determines what's possible in terms of building districts that satisfy the lines there. So again, this I think is a really useful kind of tool to play around with, to build up some intuition for what sort of good maps look like in your state. If you're looking for sort of specific tasks or things to try out to sort of build up your intuition, this Google Doc, again, has some nice examples of those as well. And then I just want to wrap up by talking here a little bit about the software for sort of generating new districting plans, or these large collections of districting plans under the ensemble method. So to start with, there's a bunch of sort of publicly available data for all the states in the country, either from the census directly, or from MGDG State's GitHub repository again, or from the Redistricting Data Hub, all of which sort of provide different levels of checking on their data evaluation and sort of pulling it all together. And then these analysis that I mentioned that sort of take this perspective of trying to create a large collection, an ensemble of districting plans that satisfy some version of the state's rules. There's now some open source software for doing that, both in Python and in R, using sort of slightly different methodologies. So the one in Python is called GerryChain. It's open source. It's up on GitHub. You can install it through PyPy or through Conda. And I've linked some guides here, as well as sort of a live CodeCalc server with some templates that sort of walk through step by step of how to construct ensembles, how to incorporate some of these constraints and rules, and how to evaluate the sort of different data problems that arise there, as well as analyzing the output of these methods. The R package is called redist. It includes this implementation of a new algorithm called sequential Monte Carlo version of the sort of sampling process. And there's some really nice examples put together by Corey McCartan and Chris Kenny at Harvard. And those are linked here as well. So you can, again, sort of go look through the source code, play around with the data for your favorite state, try to get a sense for what building these ensembles looks like. And so the interface, at least for the CodeCalc version, is really straightforward. So there's a collection of Python, Jupyter notebooks up on CodeCalc that you can access as a starting point to play around with, to walk through some common states and some common examples for analysis there. And so I think I'm out of time, but hopefully you'll take an opportunity to sort of play around with some of these examples. And I certainly encourage you to reach out to me or to get involved in your own state with working on these sort of redistricting problems and getting involved from a computational and data perspective. Thanks.